right, let's talk about piecewise defined functions. A piecewise defined function you might have encountered in your life is federal income tax, because you get taxed at different rates depending on how much income you make. So if you make between $0 and $14,000, they take 10% of your income. If you make between $14,101 and $53,700, you get 10% of the first 14,000, and then they take 12% of the next amount of money. And if you make between these two amounts, you get charged 10% of the first 14,000, 12% of the next 53,000, and then 22% of everything after that. So that's a piecewise defined function. Let's look at the graph. So you can see that the slope is changing for the different parts of the domain. So for this part of the domain, the slope is 10%. That's a 10% tax rate. For this part of the domain, the slope is higher. And these are actually connected. Well, in real life, they round it up to the nearest dollar. All right, let's look at a simpler piecewise defined function. So suppose we have f of x, which is 5 for x greater than or equal to 2, or 3 for x less than 2. Let's look at the graph of this piecewise defined function. So for this part of the domain, x less than 2, f of x is 3. And then for this part of the domain, x greater than 2, f of x is 5. You'll notice there's an open circle here because x is strictly less than 2, so that point is not included in the solution set. And this one is a closed circle. And we talked about this in the last section, but this little jump in the graph is called a discontinuity. And I'll show you how you can type that into a graphing calculator. All right, you want to type in a function that you're going to graph. So that's y equals. So 3 for x less than 2. So you're just going to put in parentheses x and then test. And that's number 5 less than 2 plus, I don't know if you need 5 in the parentheses, but, and this is going to be for x and then test. Number 4 greater than or equal to 2. And we'll just choose the standard window. And unfortunately, the graphing calculator likes to connect the dots, but if you zoom in, you'll be able to see that jump. Let's do another. Suppose we have this piecewise defined function. F of x is x squared for x less than or equal to 0. And f of x is x plus 3 for x greater than 0. And this would be a good time to hit the pause button and try this one on your own. All right, for x less than or equal to 0, my graph is going to be the parabola with vertex at the origin. And because that's less than or equal, the origin is included. And then x plus 3 is just the equation of a line with slope 1 that goes to the point 0, 3. This is strictly greater than, so that's going to be an open circle. And it's just a line with slope equal to 1. Again, we have a discontinuity here. Because the graph makes a jump. Let's look at another. All right, let's graph f of x is x squared minus 1 for x less than or equal to 1, or 2x minus 5 for x strictly greater than 1. So I would hit the pause button and try that one on your own. Okay, so my things are going to change here. X equals 1, so I'm just going to put in a nice little dotted line. X squared minus 1 is a parabola with vertex at 0, -1. And at 1, it's actually equal to 0. So it's going to look like this. And that point, 1, 0, is included in the solution set. And then 2x minus 5 is a line with slope equal to 2 that goes through 0, 5. So it's going to start down here. Of course, we're going to start here at x equals 1. And that part gets an open circle. All right, and even if you're not going to draw the graph, you should be able to evaluate a piecewise defined function for different values of x. So you could give this one a try. All right, so if you want to define f of 4, first you have to decide. Sorry to fix that. First you have to decide which part of the domain 4 is in. Is it in x less than or equal to 3 or x greater than 3? Well, it's in this part, so we're going to use square root of x. So f of 4 is the principal square root of 4. F of 0, we have to decide which part of the domain 0 is in. And it's in this part, so we're going to use this top function. So f of 0 is 0 plus 3. What if we want to find f of 3? Well, it's going to be in this top part because 3 is less than or equal to 3. So f of 3 is 3 plus 3, or 6.